Hello everyone. Again, welcome to lecture number 3 of chapter 1, 8051 Programming in C of Embedded System course. So, in previous lectures, we discussed about introduction to embedded system, and we took overview of 8051 architecture in very brief. So today we are going to discuss data types and time delay in 8051 using C. That is, we are going to study what are data types in a C programming language that we are going to use while programming 8051 for various applications. And we are also going to discuss how to design time delays in a C for 8051 microcontroller. So first, in part 1, we will discuss these 3 points. First, programming language options available for embedded systems based on any microcontroller, and that could be 8051 microcontroller as well. Then we will see what are advantages and disadvantages of using C programming language for programming embedded systems. And then we will move our focus on various C data types that we are going to use while programming embedded systems in C. So first point is programming language options for embedded system. There are two options for programming any embedded system. First one is assembly language programming that you have studied in 8051 microcontroller course. And second option is using high level programming languages for programming embedded systems like C programming language. And when we use this C programming language for embedded system programming, we popularly call it as embedded C. Okay. Another meaning of embedded C is just extension of C programming language, and name signifies since it can be embedded into any third-party compilers. For example, Kill compiler. So you have studied Kill compiler for programming 8051 microcontroller in assembly language programming. So with this Kill compiler, C compiler, that is embed C compiler, also comes, and that we can install with Kill compiler, and we can use then that Kill compiler for programming embedded system or 8051 microcontroller in a C. Okay, so that C compiler or embed C compiler is known as Kill C51 compiler. That is the meaning of embedded C. Second point is programming in C, advantages, disadvantages. So what are advantages of using C programming language, that is high level programming language for programming embedded system? So first one is it is easier and less time consuming than in assembly programming language, because if you want to program any microcontroller in assembly programming language, then you need to know its instruction set, or you have to remember the instruction set of that particular microcontroller, and that instruction set you can use while writing programs in assembly programming language. But when you use C programming language, then it is not required to remember instruction set of particular microcontroller, because you are going to use C statements for writing a program in C for any microcontroller. So it will be easy and less time consuming while writing programs in C for embedded system. Second advantage is C is easier to modify and update. You can open any C program file in any editor, and you can understand it, and so that you can modify and update it as per your requirement. Third advantage is you can use ready-made code available in function libraries. Like you have studied in C programming course, you can include function libraries in the start of your program, and you can directly use these functions, uh, that is pre-compiled uh, functions which are available in header files. For example, in the start of your program, if you include math.h header file by using directive include #include, then you can use mathematical related functions readily available in this header file. Similarly, you can include such function libraries in your program, C program you are writing for any embedded system, and you can use this ready-made code available in the form of function libraries. That is the third advantage. Fourth advantage is C code is portable to other microcontrollers with little or no modification. For example, if you write a program for a particular application, for a particular microcontroller in a C, then um, you can use you can use same code for any other microcontroller with just very little modification in the program, but that is not applicable with the program written in assembly programming language. Okay, so that is the fourth advantage. There is one disadvantage of using programming in a C for embed systems, and that is larger size hex file, since microcontroller have limited on chip ROM. So hex file will get created when you compile your C program. That means that program will get assembled into hex file, and the if you compile C program file, it will generate hex file of large size as compared to same program if it is written in assembly programming language. That is the disadvantage, because microcontroller have limited size of on chip ROM, so we must take care of size of that hex file for a particular program, for a particular application, so that should not exceed the actual size of on chip ROM of that microcontroller. So that is the disadvantage. Now we are going to study how to program uh, 8051 based embedded system in a C programming language. For that, we need to study or revisit C data types. Okay, you have already studied these data types in a C programming language course. Again, we are uh, very briefly going to discuss these data types. Uh, so the data types of which are of use while programming embedded systems based on 8051 microcontroller in C, that are listed here. First one is unsigned char, second is signed char, third one is unsigned int, fourth one is signed int. So these first four data types you have already studied. We are going to study in details, and three more data types which are marked in red here, you can see, that is s bit data type, and bit data type, and sfr data type. So we are going to discuss all this in details. So first one is unsigned char data types. So since 8051 is 8-bit microcontroller, character data type is a natural choice for many applications. So 8051 is 8-bit microcontroller means its word length, or the word length of central processing unit of 8051 microcontroller is of 8 bits. That means whatever arithmetic and logical unit inside CPU of 8051 is capable of processing 8 bits of data at a time. So that is the meaning. So if that is the case, if that means 8051, since it is 8-bit microcontroller, character data type which requires 1 byte, that is 8-bit size, is a natural choice for many applications. Means majoritarily we are going to use this character data type while programming or while writing programs in C for 8051 microcontroller. That is the meaning. Unsigned char is actually ranges from 0 to 255. Means if you declare unsigned char type of variable that can hold value in between 0 to 255 in decimal, or 00h to ffh in hexadecimal. So for illustration of use of this unsigned char data type, I have taken one example, very simple example. So objective is to write an 8051C program to send values 00 to FF in hex to port P1 of 8051. So 00 to FF means in decimal 0 to 255 we have to output to port P1 from starting from 00 to FF. So for that I have written program here. So see the program. So I hope you remember the program structure in C. So first is this is include directive hash include and reg51.h. Now what is this reg51.h? Reg means registers and 51 means 8051 microcontroller. So if you are going to write C program for 8051 microcontroller, you have to include this reg51.h header file in your program in the start. Okay, so what is in this reg51.h header file we are going to discuss. Then you know that any C program should consist of one or more than one function, and out of these number of functions, one function should have name main. Okay, now this program consists of only one function, and that should have name main. Okay, so this is main function. Void main void means we are not passing any value to this function, and it is not returning any value. That is the meaning of void main and void here in parenthesis. Void means we are not passing any value to this function, and this void means data type of this main function. That means it is not returning any value. And in between opening and closing braces, main program is written. Now see this program here, unsigned char z and semicomma. So this statement is declaring z as unsigned char type of variable. Means in z I can store value in between 0 to 255 in decimal, or 0000 h to ffh in hexadecimal. That is the meaning. Next statement is for statement for z in a parenthesis. There are three expressions: expression 1, expression 2 and expression 3. Expression 1 is initialization expression, expression 2 is a relational expression, and expression 3 is actually this is increment uh, a statement. Uh, so this first expression will be executed only for once. So z is equal to 0 means z will get assigned value 0. Then this expression 2 will be evaluated. So this is a relational expression. Z is less than or equal to 255 means this is the condition that will be checked, and means this expression will be evaluated and it will return either value true or false. Okay, so here right now in Z value is 0. So 0 is less than or equal to 255 means this statement or this expression will return true value. If it returns true, then the statements in this for loop will get executed. Right now there is only one statement in this for loop, and that is P1 is equal to Z. So this is the only statement, so it is not enclosed in between opening and closing braces. If this for loop does have more than one statements in the loop, then these statements should be enclosed in between opening and closing braces. But right now here we have only one statement in the loop. Okay, now this expression returns true, so this statement in the loop will be executed. So P1 is equal to Z. Now what is this P1? P1 means port 1. This P1 means port 1, but in your program you haven't declared any P1. So first time it is occurred here P1. So how your program knows that P1 is port 1? So that is due to we have included this reg51.h file. In reg51.h file, so p1 is defined as port 1, means p1 is defined with, or p1 is assigned with value of address of port 1. Okay, so when this statement gets executed, what exactly happens? Value in z will get outputted to port 1. That is the meaning of this statement, that is p1 is equal to z. Z मध्ये काय आहे? 0 आहे. This value will get outputted to port 1. After that, expression 3 will be evaluated, means z will get incremented by 1. Z plus plus means z is equal to z plus 1. So z will get incremented by 1. Again this expression 2 will be evaluated. If again it is returns true, again this statement will get executed. So z, now it is having value 1, still it is less than or equal to 255, means it will returns true. Again this p1 is equal to z statement will be executed. Now p1 port 1 will get assigned value in z, that is 1. In this way port 1, um, at port 1 values in z variable will get outputted. Okay, so it starts from 0, it will go up to 255. Okay, so values from 0 to 255 will get outputted to port 1, and when again after that if z is incremented by 1, means it becomes now 256, then this expression 2 will get evaluated to false, and this statement in loop will not be executed. That will terminate this loop, for loop, and program execution ends. Okay, in this way this program is outputting value in z to port 1, and value in z is varying from 0 to 255, and that is been asked in this program, that is we have to send values 00 to ff, that is 0 to 255 to port p1. Okay, in this way I can use this unsigned char type of data type. So this is what reg51.h header file looks like. If you open this header file reg51.h in text editor, it will look like this. Okay, so in this here I'm using SFR data type. SFR P0 is equal to SFR P0 is equal to 0x80, because 0x80 is the address of port 0. Okay, so I'm declaring P0 as SFR data type variable, and I'm assigning value 80 to P0 because port 0's address is 80. Similarly, I'm declaring P1 of SFR data type variable, and I'm assigning value 90, means P1 means port 1, port 1's address is actually 90. Okay, so P0, P1, P2, P3, these are actually variables I'm declaring of SFR data type, and I'm assigning addresses of respective ports to these variables P0 to P3. Okay, so in this way all these SFRs available in 8051 microcontroller are assigned with addresses, their actual physical addresses. Okay, for example, see here SFR PSW is equal to 0xD0, where D0 is the address of program status word SFR. Here SFR ACC is equal to 0xE0, so 0xE0 is the address of accumulator. So I am declaring ACC as accumulator. Means simply I am assigning these symbols to various SFRs, and so that from my program I can use these symbols, okay, instead of these addresses, because it may not be possible for me to remember all these addresses, and if I write program by using these addresses, so you will not understand that program. So that's why I'm using this reg51.h header file. Okay, so all SFRs are declared or defined in this header file. So one more program. So one more program, write an 8051C program to send hex values for ASCII characters of 0, 1, 2, 3, 4, 5, A, B, C, D to port P1. So we are going to output ASCII codes of 0 to D to port 1. So see here the program is written for that. So I'm including reg51.h file first, and in main function I have written program. First I am declaring my num as unsigned char type of array, because here opening and closing brackets are here. Okay, and to this I am assigning this string. This is called a string because it is enclosed in between opening and closing um, double quotes. Okay, so here in this my num array, okay, in which each element of this array is of unsigned char, means value can range in between 0 to 255 will be there. And in this my num array I am storing 0 1 2 3 4 5 a b c d, means first element will be 0, second element will be 1 2 3 so on. Means first element will be ASCII code of 0, second element will be ASCII code of 1, will get stored in this my num array, so on up to d. Okay, so 1 2 3 4 5 6 7 8 9 10, 10 elements are there in this my num array. First element is ASCII code of 0, second element is ASCII code of 1, and so on, and last element is ASCII code of d, that will get stored in my num array. One more unsigned char type of variable I am declaring, that is z, and then I am writing loop, for loop. In this loop there is only one statement, and these loops, the expressions are here. Expression 1, initialization expression, z will get assigned with value 0. Okay, then this is a relational expression, z is less than or equal to 10, means this loop will be repeated only for 10 times, 0 to 9, 0 to 9. So here it should not be equal to sign should not be here, z is less than 10, that should be the expression 2. Otherwise this for loop will be executed 11 number of times. And last expression, the expression 3 is z plus plus. Now what will happen? First, when this for loop executed, this expression will expression 1 will be evaluated, so z will get assigned value 0. Then this relational expression will be evaluated. Since z is having 0, this expression will evaluate to true value, so the statements in this for loop will be executed. So what is written here? P1 is equal to my num in square bracket 0, means port 1. To port 1 we are assigning value in my num array. Which value? Z is having value 0, means element number 1. So my num in square bracket 0 means element number 1 in this my num. And what is element number 1? That is ASCII code of 0, means first we are outputting ASCII code of 0 to port 1. Then z plus plus, this expression 3 will be evaluated, means z will get incremented by 1. Then again this expression 2 will get evaluated, since it returns true, because now z is having value 1 and still this expression returns true. So now since this expression returns true, again this statement in the loop will get executed. So my num now value in z is 1, so my num 1 means element number 2 in this my num array, that is ASCII code of 1 is the element number 2 in my num array, and that value will get assigned to port 1. Okay, in this way this loop will be repeated 10 number of times, and it will output ASCII codes of 0 1 2 3 4 5 a b c d to port 1. In this way we are actually outputting ASCII codes of 0 to d to port 1. Okay, so one more program is there. So write an 8051C program to toggle all the bits of port 1 continuously. So same, include reg51.h. So what we are going to do, we are going to toggle all the bits of P1. Okay, means for first we will output 10101010 to port 1, and then after that we will output 01010101 to port 1. Okay, and in hex these values are 55 and AA. Okay, means continuously if you output 55 and AA in hex to port 1, so it will toggle port 1. So for that program is written. Okay, so first I am including reg51.h header file, and then this main function. Okay, in between opening and closing braces, this is the for loop. Now this for loop consists of two statements, so these are enclosed in between opening and closing braces. And here there are no expression 1, expression 2 and expression 3, because we are continuously going to toggle port 1. Okay, so this is infinite loop. So if you write for loop like this, means it will execute infinitely whatever statements inside this loop. So here P1 first, for port 1, we are assigning 0x55, means 01010101 will get outputted to port 1, and after that we are outputting A8 to port 1, means 10101010, means continuously these loop statements will be executed, toggling the bits of port 1. Okay, so this program toggles all the bits of port 1 continuously. Uh, Next C data type is signed char. Signed char data type. So signed char is 8-bit data type, and MSB 7 bit is used to represent minus or plus, and signed signed char text values in the range of -120 to +127. So for that a program, here program is written. We will revisit this program. First we will take a look on all the data types. Next is unsigned int. Okay, so unsigned int is a 16-bit data type. Unsigned int text value in the range of 0 to 65,535 in hex 0000h to FFFFH. Since registers and memory addresses are in 8-bit chunks, the misuse of int variable will result in large hex files. So you have to seldomly use unsigned int data type, because actually 8051 is 8-bit microcontroller. And what is use of this unsigned int data type? So it is used to declare 16-bit variables used to hold memory address. Okay, that is the use of unsigned int. Signed int is a 16-bit data type again, and MSB, that is D15 bit, is used to represent minus or plus. So D15 bit will be 1 if number is negative, and it will be 0 if number is positive. And signed integer text values in the range of -32,768 to +32,767. Okay, in hex that ranges from 0000h to FFFFH. So this is a new data type, S-bit data type, new single bit data type, and this data type is used to represent a single bit of any SFR register. Okay, for example, port 1 bit 0, if you want to represent, okay, then you can use this S-bit data type. Okay, so that is the meaning. So here is one example. Write an 8051C program to toggle only bit P2.4, means port 2 pin number 4 continuously without disturbing the rest of the bits of port 2. So here that is, we are going to toggle a particular bit from port 2, and that bit is bit number 4, that is pin number 4. So program is written for that, hash include reg51.h, and I'm declaring my bit as S-bit type of variable, my bit, and I'm assigning my bit with address of pin number 4 of port 2. That is the meaning, means my bit is now representing pin number 4 of port 2. Okay, means in remaining program I can refer pin number 4 of port 2 by using name my bit. That is the meaning. So S bit means a bit from SFR. I am declaring my bit as another name for pin number 4 of port 2. That is the meaning. So this is main program, void main void, and in between opening and closing braces while 1, means this is infinite while loop, means whatever statements in this loop will execute infinitely. So my bit is equal to 1. So this statement, so what it will do, it will set this P2 port number 2 pin number 4, because my bit is what, that is pin number 4 of port 2, pin number 4 of port 2. So I'm assigning it with value 1, means first this pin will get set, and after that what I am doing, my bit is equal to 0. Now I am resetting this bit, means I'm making first pin this pin port 2 pin number 4 1, and then I'm making 0. Again these loop statements will execute. Okay, again I'm making it 1, again I'm making it 0, means continuously we are toggling pin number 4 of port 2. Okay, so this illustrates how I can use S bit data type. Okay, so that is the use of S bit data type. Next data type is bit. Okay, so this is this bit data type is used to represent a bit from bit addressable RAM, that is starting from address 20 to 2F. These 16 bytes are bit addressable, and I can represent any bit from these 16 bytes by using this bit data type. How we are going to study. And last C data type is a new SFR data type, and this SFR data type is used, um, it is used to represent any SFR register. For example, port 1, if I don't want to represent port 1 by using its standard name P1, then I can use this SFR data type like SFR port 1 is equal to address of that port 1. For example, whatever address 0x90 is the address of port 1, so that will get assigned to port 1. So these are summary of C data types. First column is data type, second column is size in bits, and third column is data in range. Okay, so we'll stop here. We will continue with part 2 in next lecture.